Hey there, folks. Welcome to another episode of Quick Bites of AI, your go-to place for serving up a tasty morsel of artificial intelligence knowledge. Today, we're diving into the wonderful world of normal distribution. I know, you might be wondering, what's so normal about it? Oh, trust me, it's anything but time just times normal. It's actually pretty extraordinary. So let's start with the basics. What exactly is a normal distribution? Picture this. It's like a bell, those handbells they use in schools. When you plot the data, it forms this smooth, symmetric, bell-shaped curve. That's why it's often called a bell curve. The peak of the bell at the center represents the mean, or the average of your data. And as you move away from the mean, data becomes less and less frequent. The beauty of the normal distribution lies in its symmetry. The left side is a mirror image of the right side. Think of it as the Mona Lisa of data representations. Perfect symmetry. Well, almost perfect, because real-world data can be a little messy. Now you might be asking, why should I care about this bell curve? Well, in AI and ML, understanding the normal distribution is crucial because it pops up times everywhere. From error analysis to modeling natural phenomena, it's like the Swiss Army knife of statistics. Plus, many algorithms assume that your data is normally distributed, so knowing this can actually save you a lot of headaches. Here's a quick example you might relate to. Imagine a classroom full of students taking an exam. If we plot their scores, most students would get average scores, with few getting really high or really low scores. Voila! You've got a normal distribution, but life isn't always a bed of roses. Or should I say, not everything fits this bell-shaped model. It's important to identify when your data follows this pattern. How can you do that, you ask? Well, one way is visual inspection. Plot it out, like I mentioned with the student scores. But let's not forget the numbers. Look for skewness and kurtosis, which sound like fancy spell names from Harry Potter, but they're actually just statistical measures to help you out. Oh, and a quick word about the parameters that define this bell-shaped beauty: the mean and the standard deviation. The mean tells us where the center is, and the standard deviation tells us about the spread, how wide or narrow our bell is. If you get all techie, you might even hear these data scientists toss around terms like 6895 minus 99.7 rule, which kind of sounds like a cheat code, right? But it's just saying that 68% of our data falls within one standard deviation from the mean, 95% within 2, and 99.7% within 3. Now, let me throw in a joke here. Why did the data scientist break up with the normal distribution? Because it had too many assumptions. And speaking of assumptions, don't just assume all your data is perfectly normal. Much like people, always check, because things like outliers can mess up your analysis. And an outlier just screams, "Hey, I'm special!" But in a normal distribution, it's kind of that noisy roommate you'd rather not have. So folks, when you're dealing with AI and ML, always ask yourself, is this a job for my buddy, normal distribution? And treat it with caution. It'll make working with algorithms and models much smoother, and maybe a little less chaotic. That's all for today on Quick Bites of AI. Hope you enjoyed nibbling on this topic and feel a little fuller with knowledge. Stay curious, stay excited, and I'll catch you next time. Bye for now.